I'm here to tell you about a digital twin developed for one Taikoo Place in Hong Kong. I'll focus on the benefits of having a digital twin on the project and give you some real-life examples how these benefits can be unlocked and realized. Very briefly about the project. The client is Swire Properties, who owns and operates multiple buildings in Hong Kong. The building was completed in September 2019. Some of the famous tenants include Facebook, AXA, Ernst & Young, Baker, McKinsey, and so on, so quite an exclusive end. The building has a floor area of approximately 1 million square feet, and it is 41 stories high, so a typical building in Dubai. As discussed later in the presentation, this is the first AI-enabled smart building in Hong Kong, so quite an unusual feature about the building. The project aimed to achieve the highest sustainability rating, platinum, in terms of LEED and WELL. It also tried to achieve platinum in terms of the local BEAM Plus accreditation. Therefore, one of the key drivers was to unlock some of the operational lifecycle benefits of the digital twin of the project. HVAC systems account for the vast majority of the electricity use in buildings in Hong Kong. Therefore, significant electricity savings in that particular area in electricity consumption were targeted. High sustainability goals necessitated to use novel ways of saving electricity whilst not compromising on occupant comfort. The digital twins gathers a range of data, and here are some examples. But of course, there is much more data that is gathered. There are CO2 sensors, there is temperature sensors, there is chilled water temperature sensors, and all this data is fed into the digital twin. And here are some graphs showing the distribution of this data in the building. So you can see different floors, different times. Occupant load numbers and the occupant load distribution is an important consideration as it affects the cooling and fresh air needs. The occupancy data was taken from the turnstile system at the reception. This dashboard shows occupancy data in the building. Such information is extremely valuable and can be used not just for the HVAC systems, but also for a range of other applications, which can be enabled actually in the future. So for instance, you might think about catering. Can I make catering more effective in the future? You can just add it in later on if you have a digital twin. You can think about lift optimization. You can add it later on in the building. This data is then fed into the digital twin. The data is processed in real time using AI-enabled algorithms. Such complex processing is needed to find patterns and oddities and arrive at an optimal solution. In this project, the main aim is to save electricity. However, digital twins have a much bigger potential, and additional capabilities can be enabled gradually as the project progresses. In essence, other applications can be added on top of the existing layer of information. Chiller and air handling units were the key systems optimized using the digital twin. In chillers, the digital twin was used to optimize the condenser water entering temperature based on the cooling predictions of the external weather. This allowed to maximize the coefficient of performance of the chillers and thus save electricity. The digital twin also observed the micro patterns in data to identify any reductions in performance, any unusual parts, and these performance variations were detected very early before any human could spot them. This information enabled better maintenance of systems to maximize their efficiency. In addition, a forecasting model using the data from the digital twin was developed to inform the replacement of the chiller water system equipment. And here you can see some very pretty representations. So one aspect is actually using the data, optimizing the building use and making it clever and more cost effective. But another aspect is just having an asset that you know what's happening and you can play with the data, you know what you have. The air handling units are controlled by the digital twin to provide fresh air when needed and in the quantity that is required without being wasteful. The amount of fresh air entering each level is informed by the CO2 sensors, and the occupant load numbers so that the quantity of air is within a comfortable range. And that is very important because our clients are high-end. They don't want cold air and in low quantities. Similar to the chillers, predictive maintenance was adopted, and equipment replacement forecasting were also applied to the air handling units. So what is the outcome? Is the building any better than a well-designed building without a digital twin and an AI-enabled platform? Because this is something that we are quite used to. And the answer is yes. Together with the client, we have estimated that the HVAC energy use as a result of using a digital twin on this very project is between 10 to 20% saving. This is a huge operational saving if you consider that the building is 1 million square feet. And this is a 41-story building. And here in Dubai, we have much bigger buildings, much higher. The project has received multiple awards, including awards for innovative applications of a digital twin. So I think that just demonstrates that it's quite novel.
Which digital twin platform did you use?
ARUP at the time developed a new platform, actually called Neuron. And this was developed by ARUP and then became a spin-off company. And we used that platform to gather the data and process the data. And these images that you saw were part of that platform. But there are, of course, many other platforms, and we as ARUP support using anything that works.
So Neuron is a system that ARUP developed. Has that gone commercial?
It is already commercial. It is used. Yeah, I can get you in touch with Neuron. And the key aim of Neuron and the key aim of also ARUP is to build on the idea of we have the hardware, we have the data, and now it's all about the clever processing of data. So this is where we, as ARUP, are interested in. And Neuron is just one way of looking at the data, using AI, finding the best fit and the best outcomes of the data. Like I mentioned that the chillers, you can switch them on and off, but you can also monitor the performance. You can also use the weather data to influence how well the coefficient of performance works. So this is the area where we're.
You talked about predictive maintenance, which would mean obviously you gotta identify the potential failure before they fail and then address them. Does Neuron have the capability to tie in the digital twin system with the maintenance management system like Maximo to really dispatch the contractors to do the work?
I'm not sure whether the Neuron has this capability. So the way Neuron works, or the way the solution here works, is that we observe differences in data, so some odd instances where the data doesn't line up. And this is how we know that something is not working here, or that the coefficient of performance is diminished. And then there is this information, okay, this is the item that you should really get checked. Neuron is just one of the platforms. We could use any other platform for that purpose. It's just to use as AI.